Hi everyone, welcome to Physics Academy. In today's video lesson, we'll be learning about a topic called elasticity. Now, without wasting most of your time, let's quickly get down to today's class. Now, for the purpose of this class, I have grouped the topic elasticity into three major aspects which is commonly asked for in an exam condition. Mind you, this is a revision class. So, the first aspect is called Hooke's law. The next one is Young's modulus. And lastly, we'll be talking about work done or energy stored in a spring or an elastic string. Now, coming back to Hooke's law, there are a number of formulas to be noted. There are a number of formulas to be remembered for the purpose of any exam you are going to be asked. Now, the first important formula from Hooke's law is the force is equals to KE. F equals KE. Now, each of these letters or symbols have their meaning. Where F is the force, or in questions where it was not given as force, it can also be given as what? Load. That is to say, force or load is the same thing. Okay? And the unit for force, like we all know, is what? The Newton. That is symbolized by N. Now, K here is what? The elastic constant. Also called the force constant. Also called the stiffness. So, either of these can be given. They all boil down to the same K. And the unit for K, in case you were asked to calculate for it, the unit you should attach to it is Newton per meter. Newton per meter. Any of this form can be used. Okay? Now, sometimes you won't be given the extension directly. You'll be the one to find the extension yourself. And in such cases, you'll be given the initial length and the final length. Where the formula to not get the extension will be what? The final length L2 minus the initial length L1. This is the formula for calculating extension. Lastly, there is a formula that is derived from this important formula, which is what? F1 over E1 equals F2 over E2. Now, this formula applies where two scenarios are being compared. Okay? Two scenarios are being compared. They'll say if a force of this was applied to a spring and it's extended by this, what is the force required to extend that same spring by this? Look at what I'm saying. If a force of so and so Newton extend a spring by so and so meter, what is the force unknown required to extend that same spring by so and so meter? So this is the formula you make use of. Okay? Any other want to use it, this is the formula you make use of, whereby two scenarios are being compared. So now we know what is under Hooke's law. Let's quickly go straight to what? Young's modulus. Young's modulus. Now the general formula for Young's modulus is that Young's modulus is equals to the stress over the strain. Now, another way they can call this, they will say tensile stress over tensile strain. Now, what if you are not giving the stress directly? What is the formula to use to get your stress? Stress or tensile stress is equals to the force over the area. And the unit for tensile stress is what? Newton per meter square. Newton per meter square is the unit for what? Stress. Now, what if strain was not given directly? What is the formula you can actually use to get your strain or tensile strain? The formula is extension over length. That is the extension over the what? Original length. This is the formula that will give you a what? Strain. Now, if you ask me, why did I add a unit for strain? We all know extension is a type or form of length, is it not? So if the unit here is meter, and the unit for length is also meter, meter will cancel meter. That is, there is no unit for what? Strain, and therefore implies that strain is a what? A dimensionless quantity. Now, combining these two formulas, if we replace stress with this over and replace strain with this under, the formula that we'll get for Young's modulus will now be force times length over area times extension. I repeat, the force times the length over area times extension. And this is the one that is most likely asked for in exam competition. Lastly, before we close this session, the unit for Y, Young's modulus, is what? Newton per meter square. Newton per meter square. Any of the form, they boil down to the same Young's modulus. Now we know this, without wasting time, let's quickly look at the work done or energy stored in a spring or elastic string. Now, the formula, if you are asked to find the work done, is the same formula if you are asked to find the energy stored. That's what I mean by this statement. Now, what is the general formula? It's either you are using 1 over 2 Fe, where we all know that F is load, also called force, and E is what? Extension. Or we are using half Ke squared, where we all know that K is what? The elastic constant, or the force constant, or the what? Stiffness. And E is also what? The extension. Or we are using the last formula for work or energy, which is what? Half F squared over K. F is force or load, and K is what? Elastic constant, force constant, or what? Stiffness. Now, lastly, the unit for work or energy, we all know it to be what? Joule, symbolized as what? J. Now we know this. Before we start taking questions, there's something important I would like to add under Hooke's law. Okay? So I will be writing it here, so you can actually see what I have to tell you guys. If in the question you heard something like, let me just add it underneath. You heard something like stretch by, emphasis on the by. Or you hear something like compress by, emphasis on the by. Or you hear something like extend by, emphasis on the by. So they will tell you something like a spring is extended by 2 cm. That 2 cm that follow, what does it stand for? Is it the final length, is it the initial length, or is it the extension? The answer is what? It is the what? Extension. It is for the extension. And we know extension is what? E. Is it not? So stretch by, compress by, extend by. The value that follow after any of these is for the what? E, extension. But if you hear something like stretch so, or you hear something like compressed so, or you hear something like extend or extended, anyone so, these guys is for the final length. And the final length is what? L2. Don't go and make the mistake of using it as your extension. Why am I giving this distinction? Because when this is the case, the value that follow after is for the extension. But when this is the case, the value that follow after is for the what? Final length. So you know the what? The difference between the two. So now guys that we have all these formulas on the board, without wasting time, we'll be taking 1 or 2 questions under elasticity for the purpose of revision, and then I will drop one for you guys to try out and let me know what the answer is. So without wasting time, let's get down to the question now. Alright, here are the questions we are asked to answer under elasticity. So without wasting time, let's get started. The first question was, a force of 1.8 Newton extend a wire by, extend by, that should be for what? Extension, is it not? Good. If it was extend to, it will be for what? The final length, L2. Now let's continue reading. What force will extend that same wire by 12 cm, provided the elastic limit is not exceeded? This statement, provided the elastic limit is not exceeded, is from what? Hooke's law. And every material that is said to be elastic must obey this statement, which is from what? Hooke's law. So now we have the question. Without wasting time, let's start solving. Solution. Let's take the question and let's, first of all, let's derive what I was given in this question. They said a force. Now, remember we have gone through the question, we have seen that they are comparing 2 scenarios, you know. So the first force that was given, we'll take as F1. So when they said a force of 1.8 Newton, we say F1 is equals what? 1.8 Newton. Okay? They said extend a wire by. Extend by. That should be for what? From what I wrote there, it was what? E. Is it not? Whenever you get extend by, compress by, stretch by, it should be for the what? Extension, which is E. By what? 4 cm. So this is E1. I hope we are clear on this. This is for what? E1. Then we continue. They said what force? That is to say the second force is unknown. The second scenario force is what? Unknown. So we present it as what? F2. Unknown. Because that's the question. What force will extend the wire by? We that same wire, we stretch it by what? 12 cm. We don't know the second force, that's why we asked to what? Calculate. So this is F1 E1, F2 E2. Now what is the most suitable formula for this question? The answer is what? F1 over E1 equals F2 over what? E2. So now we know the formula to use. Simply impute all that was given into this formula. What's our F1? 1.8 over, what's our E1? 4 equals to, what's our F2? Unknown. So you will leave it as F2. All over, what is our E2? This E2. What's our E2? The answer is what? 12. So now you have got into this place. What do you simply do to make F2 the subject of the formula? You cross multiply. F2 times 4, F2 times 4 will be equals to 1.8 times 12, is it not? So we need our calculator here to be able to what? Solve this part of the question. So because we are looking for F2, we simply divide both sides by what? 4 over 4. So we now say F2 is equals to cancel. So what is left here is what? F2. So let's work this part of the question with our calculator. 1.8 times 12 will give you 21.6. Now divide it by 4 without wasting time. The answer is what? 5.4. Now because it's force, we are asked to find, we add what? Newton. And this is the answer to the question. So I hope you clearly understood how I got the first answer to this first question. So without wasting much time, let's go straight to what? Question 2. So we say solution. Let's see how we can attack this question, guys. They said a load. Now I told us that whenever we see load, it's the same thing as what? Force. You see now, so you come and write F equals a load of what? 20 Newton. Good. 20 Newton, comma, acts on a wire of cross-sectional area. This is what matters for us. Cross-sectional area. And what is the value that follows after? 8 times 10 raised to what? Minus 7. So say the area is what? 8 times 10 raised to what? Minus 7. Now confirm it. What is the unit for the area they gave us? Meter square. Mind you, if it was not given in meter square, you have to what? Convert to meter square. Now let's continue. Producing an extension E. That's the extension of what? 10 raised to the power minus 4. So you come here and write 10 raised to the power minus 4. Now what is the unit they gave us for the extension? Meter. Now if it was not meter, let's say cm or let's say millimeter, you have to convert to what? Meter before you what? Use it. Okay? But it was given directly as what? Meter. Okay? So let's continue. They now said calculate the Young modulus. That is, the Young modulus in this case is what? Unknown. So we say y is what? Unknown. Comma. They now said calculate the Young modulus of the material of the wire if its length, that is L, is it not? L, they say is what? 3 meter. Now, was it given as cm? No. So we will not convert. It was given directly as what? Meter. If it was given as centimeter or millimeter, you will first of all have to convert to what? Meter before you use it. Okay? Now, looking at all these parameters given, what is the most suitable formula under Young modulus that can be used to what? Solve this question? This one was because we saw provided the elastic limit is not exceeded. That doesn't mean that it's what? A Hooke law question. Is it not? It's a Hooke's law question. But now we are asked to find Young modulus. So this is under Young modulus. Which of the formula is most suitable? The answer is what? The formula that states that y equals what? Force times length over what? Extension. Area times what? Extension. This is the right formula to use for this question. So what are we looking for? We are looking for what? Y. So let's just simply impute all this that was given into this formula and see what our answer will what? Be. So we say it equals to, what's our force? 20 times, what's our length? 3. All over, what's the area given? They said 8 times 10 raised to what? Minus 7. Thus then means times. have the same base for these two. The same base for these two. You pick one of the base. Now, what is the first power? Minus 7. Because it's times connecting the two, you will add. What is the second power? Minus 4. So this is what we have here. I hope you have seen it clearly. So let me continue. It will now be 60 over 8 times 10 raised to power minus 7 plus times minus is minus. Are you seeing that? Then what? 4. So what do we now have is 60 over 8 times 10 raised to power. Now, minus 7 minus 4. You will do what they call negative addition. The answer is minus 11. So from here, what do you now have? Bring this 10 raised to power minus 11 upward. You will now have 60 times 10 raised to power. It will no longer be minus 11. It will now become what? Positive 11. Are you seeing that change? Whenever you are bringing a number from the denominator to the top, the power will change to what? Positive if it was negative. Okay? But if it was positive under here, once it comes up to become what? Negative. That's the principle to be followed. All over, what will now be left here? Is it not 8? So, if you work this out with a calculator, 60 divided by 8, let's see what that will give us. 60 divided by what? 8. The answer is what? 7.5. Now, what do we have for the rest part? Times 10 raised to power what? 11. This is the answer for the what? The Young modulus. This is the answer for the what? The Young modulus. Okay? Now, what is the unit for Young modulus? Add what? Newton meter raised to power what? Minus 2. So, 7.5 times 10 raised to power minus 11 raised to power positive 11 Newton meter raised to power what? Minus 2 is the answer to this question. Just know the procedure and everything will fall into place. So guys, this is basically the question we'll take today under elasticity. So a person now be giving your own question to try your answer on. Do you want to let me know what you think the answer is in the comment section? Alright, here's the question we are asked to solve under elasticity. It reads, a spring is extended by 0.04 meter when a force of what? 50 Newton is applied to its free end. Calculate the work done on the spring. Now this is under what? Work done. You see not? So that's the third statement under elasticity. So the right one I was giving, extended by stand for what? Extension. You see not? And you're giving the force. So pick the right formula and solve for the what? The work done. Do well to let me know what your answer is in the comment section. Thanks for watching. I hope you find this video helpful. Do well to share the video with your friends, neighbors and classmates so that they too can also get to know the important formula under elasticity and have some questions on elasticity have been solved. Thanks for watching. I remain Ifizademi. See you in my next video.